Away from the sine and cosine graphs, we're going to be doing what they call a phase shift. We're shifting either left or right. They'll avoid phase shifts a lot in future settings, only because if you phase shift, like we saw before, a cosine function, you can get the sine function. So oftentimes they'll say assume no phase shift happened when they ask about questions, because you can get one from the other and it gets super confusing. But they are going to have us just practice with phase shifts because they care about us and they want us to practice the same skills that they did back when we were in algebra. And so, in the same skills we practice at the beginning of this class, we know that what x squared looks like. It is up like that, right, at 0, 0. And that a plus 1, we've been using that. They don't call that a phase shift. That's a shift up 1 unit. And they have this one that's being shifted. And do you know which way it's being shifted? That's right, it's being shifted left 1 unit, right? Everything is, in the parentheses would be the opposite, much like with the circles and things that we worked with. With circular function, a horizontal translation is called the phase shift. In the function f of x, the input value is called the argument. And so when we look at just the general one, here's the combination. So let's talk about what these things are going to do. This a right here, that is going to be the amplitude. B, let's highlight that in a different color. B is going to be the way that we get the period. I'll put allows us to find the period. D is something new to us. Let me come over here, apologize, and get D. D is the phase shift. Right? This is, we're going to shift left and right, and we know what C is, right? C is the up-down type of thing. So let's practice with something that we haven't done yet, and that is the phase shift. So my recommendation is make it easy on yourself. So what do I mean by making it easy on yourself? Do things in pencil. So what I'm going to do is I'm going to come in here, and I'm going to draw a regular sine function. So here's my regular, I'm going to just put my x-axis way over here because that's what I like. I'm going to come in here and put my, I said the x-axis, there's the y-axis. I'm going to put my y-axis way off on the left and my x-axis coming across the front, and here's 0. I note that the sine starts at 0. I know that it goes up to a height of 1, down to a negative 1. I'm sorry, down to 0, then down to negative 1, then back up to 0, then negative 1. And I know that this is 0. This is pi over 2, this is pi, this, and so forth and so on. Now I'm going to stop labeling because the labeling that I'm doing is going to be erased. But this is the regular sine function, right? Just stepping everything through here the best that I can, and a bunch of periods of it. So there's my regular sine function, up a height of 1, down a height of negative 1. Now that's not going to change because I didn't move this thing up or down. But I did move it left and right. Now, where did I move it? I moved it right pi. Okay, so I moved this thing right pi. So the whole thing's being shifted forward pi units. And so maybe it would be helpful to have had a part of it towards the back. So what I'm going to do is come in here, and because I'm doing this in pencil, I'm going to create a new 0 point. I'm going to let this right here, this point right here, be my new 0. So let's pretend that I drew the function, the sine function, just like this. Here's the 0, right? Here's 0, 0. This would have been negative pi over, no, that would be negative pi. This would be negative pi over 2, right? Coming through there. And so forth and so on. So there's my sine function, and I gotta shift it. This guy is telling me, I'll highlight that, that's telling me two things: right pi units. So picture that happening. Picture this function rolling forward pi units. Well, that would mean this line would go back pi units. And so now I'm going to come and I'm going to make my 0 line right here. And this literally is my 0 now. It was my pi, but now it's my 0. And this is the new graph. So my big recommendation with phase shift is just draw it normally and then just put in the new x-axis. Now, I mentioned that I didn't want to do any labeling at first because I was going to change it. So this is the 0. So this literally is pi over 2. So what I'm claiming is that if you plug pi over 2 into that, you're going to get -1. This is literally pi. This is 3 pi over 2. And this is literally 2 pi. So I'm claiming that. Let's watch something happen. Let's plug in pi over 2. What's the sign of x minus pi over 2 when x is equal to pi over 2? Okay. Oh, I'm sorry. X minus pi. Apologize. That's what the original function was. We're going to have a problem there if I did that. So what's that? That's the sign of pi over 2 minus pi, which is the sign of negative pi over 2. So what is the sign of negative pi over 2? Well, here's the angle negative pi over 2. So I can use that as a reference. Sine corresponds to the y. Oh, that is -1. And so when you plugged in pi over 2, you got a y value out of -1. If I plug the pi in, I'm going to get a 0. So notice pi is my new 0. That's the other way to have thought about that, is that pi is going to be your new 0. What caused you to 0 out? That might have been a better way to explain that. Let me see if I can do that here. So I'm going to do the same thing. I'm going to take my sine function, and I'm going to start it right there. And I'm just going to draw my regular sine function. Up, down, up, down, whoops, down, up. And again, it doesn't have to be perfect going through. And then down, back up, and up. So this was my 0, but I'm moving everything, what's that tell me? Left 3 pi over 4. So this whole thing's going to roll forward 3 pi over 4. That means that negative 3 pi over 4 is my new 0. That's what's going to get me to be zeroed out. So I'm going to call this negative 3 pi over 4. That guy right there is negative 3 pi over 4. That means that what is this guy right here? Well, everything's still pi over 2 away, so it's a little bit crazy because my period's still 2 pi. So it gets a little bit dicey thinking about this, but this is still pi over 2 forward. So let me make sure that I get this labeled correctly for you. Okay. So this right here, we're going to say is negative 3 pi over 4. So this right here would be negative 3 pi over 4 plus pi over 2. So what's negative 3 pi over 4? If we walk forward pi over 2, which is 2 pi over 4, well, that's negative pi over 4. Okay. And then if I add another pi over 2, which is another 2 pi over 4, so that's pi over 4. So 0 is somewhere, not just somewhere, 0 is actually right in the middle of these two. There's your 0 line, and we go get that in there. Sorry, I got a little bit wonky up top. If I hit the eraser, it might just erase the whole thing. It did, because I'm using the object eraser. Okay, there's the 0 line. There's pi over 4. So at pi over 4, let's see what it is at pi over 4. So I'm claiming that it's 0, right? Is that true? So is this all making sense? And the answer is, I think so, right? If we plug in pi over 4, what is the sine? Well, what's this? What do you get with the y equals sine of x plus 3 pi over 4 if x is equal to 0? Well, you get the sine of 3 pi over 4. The sine of 3 pi over 4 is root 2 over 2. Right? You know that because you know the sine of pi over 4 is root 2 over 2. You know it has a pi over 4 reference angle, 3 pi over 4 does. In the second quadrant, it's positive. So that's probably root 2 over 2. They're definitely positive. That's what I'm claiming. Halfway through that interval, it seems pretty decent. And then I'm also claiming that if x is equal to pi over 4, well, if x is equal to pi over 4, then you have the sine of pi over 4 plus 3 pi over 4, which is 4 pi over 4, which is sine of pi, which absolutely is 0. And we're heading down from there. So it seems perfect. So if you need to know what all these things are, just keep adding pi over 2. Now, why am I adding pi over 2? Because the period didn't change. And so we're going to get this being 3 pi over 4. Okay, and then so forth and so on. You can get that all labeled out however much you can. And so that's my suggestion coming through. So this is going to be, if I go and graph this guy, what's going to change? What's going to change is I got an amplitude of 3. So if I go one thing out, 1, 2, 3, up top, 1, 2, 3 down, 1, 2, 3 down. Up. And I'm doing this with you live, right, as opposed to just showing you these videos just so you could take notes at the same time. I hope that's appreciated and not annoying. Could be annoying. Okay, so this is a height of 3. This is negative 3 going through the origin because it's sine. Now, what's this line right here? This is no longer the x-axis. This is pi over, well, not pi over 2. This is negative pi over 2 because remember it was shifted left 3 units. But even better, I think this might be better for most. I'm trying to think of what I've talked to students about in office hours and think about what zeroes this out. Because whatever zeroes that out, that's your new starting place, right? Because remember how I started right here and went up from there? That's my new starting place. And that was at 0. So what's going to give me that 0? Negative pi over 2 is. That means this is 0 right here because everything's pi over 2 away. This is pi over 2. This is pi. This is 3 pi over 2. And it becomes, if we pick it nicely, it can become really nice. 2 pi. And then my suggestion is before you hand something in, check something out that you're saying is true. I'm saying that pi over 2 should yield a 0. And it does. Pi over 2 plus pi over 2 is pi. Sine of pi is 0 times 3 is 0. Right? And you can go out and claim, hey, at 2 pi I'm claiming it's this. And you can watch that happen where you're going to be in that upper quadrant with a 1 but multiplied by 3. And you get that nice picture going on there. Now we have our first cosine. But we have something else here. This one's loaded. So they did all sines, and cosines would be the exact same thing. But this one is extremely loaded. This is, let me show you what this is. This is the most confusing piece for some. Now, I want you to compare that to what was typed out here because it was subtle. I'm going to get rid of all the craziness here. Let me get rid of all that blue wording. If you look at this, what's written here, I'll highlight the one that's cosine. There's something that's happening right here that we absolutely need to make sure that we account for so that we can properly identify the phase shift. We must factor out. So, for example, before I ever get started and be able to start identifying things, I'm going to pull the 2 out, and we have an x minus pi over 2. So let's talk for just a minute. what I would do is, there I go again. I think we're up here still. What I would do is I would put my 0 line in, and I would just draw the standard negative cosine graph. So it's going to start out at -1. The amplitude is -1. So here's where it's going to start. It's got to go up from there. So up to there. Then it's going to go to the height of 1. Then it's going to come back down. Then it's going to go to a -1. Then it's going to come back to the 0 line, up to 1, down to 0, down to -1, up to 0, up to 1, up to 0, up to 1. Now, where is the phase shift? We couldn't identify the phase shift until we took into account the factoring out. The phase shift is right here. What makes this guy right here 0? And the answer to that is nice and simple. Actually, it's pi over 2. So I'm going to take out that x-axis, and this is pi over 2. Okay. Now, what's the 2 doing to us? The 2's adjusting our period, so our new period is just plain old pi. We're going to do a full cycle pi later. So what is pi over 2 plus pi? Hopefully you know that that's 3 pi over 2. So if I go here, up, down, another full pi would be 3 pi over 2. What's halfway in between pi over 2 and 3 pi over 2? Well, pi is halfway in between that, right? It's pi over 2 up from the 1 and pi over 2 down. So that means that this is 2 pi here. That makes sense because I'm doing 2 full rotations. Let me be careful here. Okay, so it reaches its full, yeah, no, we're good. That's pi over 2. This is 3 pi over 4. This is 5 pi over 4. 3 pi over 2. I was a little bit off on where I labeled the 2 pi, and that's what got me confused, I think. 3 pi over 2 right there. Right here at this 0 would be 7 pi. Whoops, I always have the eraser. Would be 7 pi over 4, and the 2 pi is right there coming through. So and it's because I'm forgetting that I'm starting at pi over 2, so everything's pi over 2 later. That's where I got myself confused. And then I would just check myself, does it all work out? So what's something that I'm claiming? I'm claiming that 3 pi over 2 has a -1 output. Let's go check that. Let's go put that in there, and hopefully that works. We have negative cosine of 2 times 3 pi over 2 minus pi. We just go right back to the original. So that's minus cosine of 3 pi minus pi, or minus cosine of 2 pi. Now cosine of 2 pi, so cosine of 2 pi is 1, and we got a -1 out of that. We're perfect. So just check that out and make sure it's okay. That's what I meant by checking out. And then you get more and more crazy, right? So, and then some matching at the end. Let's split this video now, and then we'll do this remainder part at the end.